Our journey does not begin with a step, but with a dive toward the incandescent center of everything. In front of us, an almost perfect sphere of plasma, bubbling with a fury that sustains all the life we know, but that would annihilate anything that dared to get too close. This is the sun, our star. It is not just a ball of fire in the sky. It is the gravitational engine and power plant of the entire solar system, holding 99.8% of all its mass. The light we see is just a small fraction of its energy. Every second, the sun turns 600 million tons of hydrogen into helium, releasing an energy output that makes anything humanity has ever produced look like a spark. The temperature at its core reaches an astonishing 15 million degrees Celsius, a nuclear furnace where atoms themselves are broken apart and rebuilt. But here, at our safe distance, what dominates our instruments is its outer atmosphere, the corona. Visible from Earth only during a total eclipse, the corona is an ethereal halo of plasma that stretches for millions of kilometers, and it holds one of the sun's great paradoxes. Somehow, this layer is hundreds of times hotter than the visible surface just below, with temperatures reaching into the millions of degrees. It is as if the air around a campfire were hotter than the flames themselves. Missions like NASA's Parker Solar Probe were designed to uncover exactly this mystery. In 2021, the probe literally touched the sun, crossing the boundary of the corona and giving us the first direct data from inside the solar atmosphere. As we navigate through this region, we see the sun's true nature. It is not a smooth surface, but a chaotic ocean of boiling plasma. Planet-sized magnetic arcs, called prominences, leap off the surface and fall back down like bridges of liquid fire. Sunspots, darker and cooler regions that can be larger than Earth itself, mark its face, signaling intense magnetic activity. And then, a sudden explosion. A coronal mass ejection blasts into space, hurling billions of tons of charged particles outward. These are the events that create space weather, which can produce spectacular auroras on Earth, but also threaten satellites and power grids. The Parker Solar Probe discovered that the solar wind, the constant flow of particles streaming out of the corona, is not a smooth breeze, but turbulent and filled with zigzagging magnetic structures nicknamed switchbacks. These magnetic reversals are like whips of energy that accelerate particles away from the sun, and the probe found that they are born in magnetic funnels on the star's surface. We also learned that about 5.6 million kilometers from the sun, there is a region completely free of dust, where the intense heat simply vaporizes any particle. It is a place of primordial power, a reminder that we live at the mercy of a force that both gives life and can take it away. But now, it is time to turn our backs on this furnace. Our journey is just beginning, and our first stop will take us to a world of extremes. Next stop, Mercury. Leaving the sun's glare behind, our craft dives into darkness, but the heat still radiates through our windows. Our target is a small rocky point, almost lost in the glow of the star we just left. As we approach, the sunlight reveals a surface that looks ancient and battered. Welcome to Mercury, the closest planet to the sun and the system's swift messenger, completing one orbit in just 88 Earth days. From afar, Mercury could be mistaken for our moon. Its surface is a testament to a violent history, covered by countless craters from billions of years of cosmic bombardment. But Mercury is much stranger than it looks. It is a planet of contradictions. Because it is so close to the sun, its daytime side reaches a scorching 430 degrees Celsius, hot enough to melt lead. Yet, because it has virtually no atmosphere to hold that heat, the night side plunges to a freezing -180 degrees Celsius. It is one of the greatest temperature swings in the entire solar system, all happening over the course of a single Mercurian day. which lasts about 176 Earth days. The landscape below us is desolate and fascinating. We see vast plains of solidified lava, pointing to a volcanic past. But what really stands out are the strange geological faults stretching for hundreds of kilometers, called Lobat scarps. These ridges are proof that Mercury is shrinking. As its iron core cooled over eons, the planet's crust wrinkled like the skin of an aging apple. Mercury is literally getting smaller. But the strangest fact about this scorched world is hidden in its shadows. In one of the hottest regions in the solar system, there is ice. Deep inside craters near the poles, there are areas that never see sunlight. In these pockets of perpetual darkness, temperatures allow water ice to exist, shielded from the star's relentless heat. Think about that. A frozen oasis in the middle of a furnace-like desert. Mercury's very existence is a puzzle. It is incredibly dense, with a massive iron core that makes up about 60% of its mass. For comparison, Earth's core accounts for only 15%. One theory suggests that Mercury was once a much larger planet. A cataclysmic impact early in its history may have stripped away most of its crust and mantle, leaving behind this disproportionate metallic core. It is not just a planet, it is the exposed heart of a lost world. As we prepare to leave, we take one last look at this small, resilient world. Mercury teaches us that the most hostile places can hide the greatest surprises. Now, we adjust our course to the next planet, a world many call Earth's twin, but that could not be more different. A beauty wrapped in poison awaits us. Next stop, Venus. We accelerate away from Mercury, and our next destination starts to grow in our field of view. It shines with a white, serene light, a milky jewel suspended in the black velvet of space. This is Venus. For centuries, its peaceful appearance led astronomers to imagine it as a tropical paradise. They could not have been more wrong. Venus is not a paradise. It is a hell in disguise. As we draw closer, the calm beauty falls apart, revealing a thick and turbulent atmosphere. We are looking at a global cloud layer, not of water, but of corrosive sulfuric acid. These clouds are so dense that they reflect most of the sunlight, which explains why Venus shines so brightly, but they also completely hide its surface. No human eye has ever seen Venusian soil from orbit in visible light. Everything we know comes from probes that used radar to pierce the veil, or that plunged to a certain depth to send us a few minutes of data. The atmosphere of Venus is its doom. Composed of more than 96% carbon dioxide, it has created the most extreme greenhouse effect in the solar system. Heat comes in and gets trapped, turning the planet into a pressure cooker. The temperature at the surface is constant, day and night, at the poles and the equator, about 465 degrees Celsius, hotter than Mercury. The atmospheric pressure is crushing, more than 90 times that of Earth. Standing on Venus's surface would be like being a kilometer underwater in the ocean, except inside an oven. The few Soviet Venera probes that managed to land lasted only minutes before being crushed and baked. But they sent us the only images ever taken from the surface. They reveal a rocky orange world under a dim, rusty yellow sky. Thanks to NASA's Magellan mission, we know that Venus is a world of volcanism. There are more volcanoes on Venus than on any other planet in the solar system. Perhaps more than 1 million of them. For a long time, scientists wondered whether they were still active. Recent data suggests they are. Missions like ESA's Venus Express found signs of recent lava flows and spikes of sulfur dioxide in the atmosphere, a gas typically associated with eruptions. Venus is not a dead world. It is alive and erupting. The big question is, why did Venus become this way? It is believed that billions of years ago, Venus and Earth were very similar, perhaps even with oceans. But because Venus is slightly closer to the Sun, its water evaporated, filling the atmosphere with vapor, a powerful greenhouse gas. This triggered a vicious cycle. More heat led to more evaporation, which led to more heat until the oceans completely boiled away. Venus is a cosmic cautionary tale, showing how a habitable world can be lost forever. New missions like NASA's Veritas and ESA's Envision are planned for the next decade to finally understand why its fate diverged so drastically from ours. As we pull away, we feel a mix of fascination and relief. Our journey now takes us home, for a brief pause in our odyssey. After the pressurized hell of Venus, the sight of our next destination is a balm for the soul. A spinning blue and white sphere fills our view. It is an oasis of color and life in a vacuum of darkness. This is Earth, our home. And from this perspective, its uniqueness is overwhelming. We have just left behind a world that boils, and one that freezes, one with no air, and another with poisonous air. And here, we see a perfect balance. We see swirls of water vapor clouds, the deep blues of the oceans, the green and brown patches of continents. At night, city lights shine like artificial constellations, a sign that matter in the universe, here, has learned to think. Earth sits in just the right place, in what scientists call the habitable zone, where liquid water can exist on the surface. But location alone is not enough. Venus is also in this zone, and we have seen its fate. Earth has the right ingredients. An atmosphere that protects us without suffocating us. A magnetic field that deflects the solar wind and prevents our atmosphere from being stripped away. And plate tectonics, a process that recycles the crust and regulates the climate. It is the only place in the entire universe where we know for sure that life exists. From the smallest bacteria in the ocean depths to the tallest sequoia, everything is interconnected. In 1990, the Voyager 1 spacecraft, on its way out of the solar system, turned its camera back home one last time, at the request of astronomer Carl Sagan. From 6 billion kilometers away, Earth appeared as a single pixel of light, a pale blue dot. Sagan wrote about that image. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, lived out their lives on a mote of dust suspended in a sunbeam. Seeing Earth from space is a transformative experience. It reminds us of our connection and our fragility. This small oasis is our only home in a vast and largely indifferent cosmos. Our stop here is brief, a moment to refuel our sense of perspective. The journey must go on toward a world that haunts our imagination. Next stop, Mars. We watch the blue of Earth shrink in our window as our course carries us farther out. Ahead, a world of ochre and rust appears. Mars. The red planet has fascinated us for millennia, first as an omen of war, and today as our next great destination. It looks familiar, yet strangely desolate, like a faded painting of Earth. Its geography is on an epic scale. We see Olympus Mons, the largest volcano in the solar system, a sleeping giant 3 times taller than Mount Everest. We see Valles Marineris, a canyon system so vast it would stretch across the entire width of the United States. Mars' red color comes from iron oxide, rust. It is a rusted world. Its atmosphere is thin, less than 1% of Earth's density, and there is not much air to breathe or protection from radiation. Today, Mars is a cold, dry desert, with average temperatures around -60 degrees Celsius. The little water that remains is mostly frozen at the poles or locked beneath the ground, but it was not always like this. That is Mars's great, tragic story. The evidence is overwhelming. Billions of years ago, Mars was a very different place. Probes and rovers, from spirit and opportunity to curiosity and perseverance, have revealed an unmistakable past. We see dried riverbeds, ancient deltas, and plains that were once the bottoms of lakes or oceans. Minerals that only form in the presence of water have been found everywhere. Mars once had a thicker atmosphere, a warmer climate, and liquid water flowing freely. It was potentially a habitable world. The question that drives us is, if it was habitable, was it ever inhabited? That is why rovers like Perseverance explore places such as Jezero Crater, an ancient river delta, and one of the most promising sites to search for signs of past life. The rover is collecting rock samples, sealing them in tubes that will one day be brought back to Earth in the hope of finally answering that question. In 2025, in our story, Perseverance made an exciting discovery, finding minerals rich in phosphorus and organic molecules, features that on Earth can be associated with microbes. It is not definitive proof, but it is the most promising hint ever found. What happened to Mars? The answer seems to lie in its size. Being smaller than Earth, its core cooled more quickly. Its global magnetic field switched off, and without that protection, the solar wind stripped away most of its atmosphere. As the atmosphere thinned, the water evaporated into space, and the planet became the frozen desert we see today. Mars is not just a destination, it is an archive. It is the ghost of a world that was once blue. Our journey now takes us beyond the rocky planets, into a completely new frontier. We must navigate through a minefield of ancient debris. Next stop, the asteroid belt. Leaving Mars behind, our craft speeds toward the vast gulf separating the inner worlds from the outer giants. We are entering the asteroid belt. You know those movie scenes where a ship has to dodge 1,000 fast-moving asteroids? In reality, it is nothing like that. The belt is a vast region, and, for the most part, empty. Although there are millions of objects, the space between them is so huge that collisions are rare. A spacecraft flying through here has very little chance of hitting anything by accident, but that does not make it less fascinating. The asteroids are leftover building blocks from the formation of the solar system, cosmic fossils that never managed to come together to form a planet. It is believed that the immense gravity of nearby Jupiter prevented these chunks of rock and metal from clumping together. Instead of a fifth rocky planet, we ended up with this ring of rubble. We see asteroids of all shapes and sizes. Most are small, but some are miniature worlds. The largest of all is Ceres, so big that its own gravity has molded it into a sphere. Ceres is classified as a dwarf planet, and observations from the Dawn mission revealed mysterious bright spots on its surface, which are deposits of salt, perhaps remnants of a subsurface ocean that leaked out. Another notable target here is the asteroid 16 Psyche. What makes it special is that it seems to be made almost entirely of metal. Scientists believe Psyche may be the exposed core of a protoplanet that was destroyed, much like what may have happened to Mercury. NASA's Psyche mission, launched in 2023, is on its way and is expected to arrive at this metallic world in 2029 to study a planet's heart without having to dig through kilometers of rock. Beyond them, NASA's Lucy mission is on a journey to visit Jupiter's Trojan asteroids, two swarms of objects trapped in the giant's orbit that may hold clues about the materials that formed the outer planets. Passing through the asteroid belt is like crossing a cemetery and a nursery at the same time. A cemetery for the planet that never existed, and a nursery preserving the raw materials of creation. Now we leave these remnants behind. The gravity ahead of us grows stronger. We are about to meet a king. Next stop, Jupiter. Leaving the asteroid belt, the scale of the solar system changes dramatically. In front of us, a world of unimaginable proportions dominates our view. It is not just a planet, it is a titan. Welcome to Jupiter, the fifth and largest planet in our system. It is so massive that it has more than twice the mass of all the other planets and moons combined. It is a gas giant, a world without a solid surface, like a star that never ignited. Its appearance is a chaotic beauty. The planet is wrapped in bands of vibrant clouds, whites, yellows, and browns, which are actually jet streams blowing in opposite directions at speeds of up to 500 kilometers per hour. And then we see its most iconic feature, the Great Red Spot. It is a colossal storm, a hurricane that has been raging for at least 400 years. The spot is so large it could swallow Earth whole. Data from NASA's Juno probe, which has been orbiting Jupiter since 2016, revealed that this storm is not superficial. It extends hundreds of kilometers down into the atmosphere. The Juno mission has revolutionized our understanding of Jupiter, flying dangerously close to the cloud tops. It has given us unprecedented views of the poles, a chaotic swirl of enormous blue cyclones arranged in geometric patterns that scientists are still trying to explain. Juno has also probed Jupiter's mighty magnetic field, 14 times stronger than Earth's, which creates incredibly powerful auroras at the planet's poles. But Jupiter is not just a planet, it is a miniature solar system. It has a faint ring system and at least 95 moons. 4 of them, the Galilean moons, are fascinating worlds. There is Io, the most volcanically active body in the solar system, whose surface is constantly reshaped by hundreds of volcanoes. There is Europa, with its cracked ice surface. Beneath it, scientists believe a vast saltwater ocean exists, with more water than all of Earth's oceans combined, making it one of the most promising places to search for life. There is Ganymede, the largest moon in the solar system, bigger than Mercury, and there is Callisto, an ancient, heavily cratered world. The Juno mission has been extended at least through 2025, continuing to uncover the secrets of this gas giant. Leaving Jupiter behind is like departing an empire. Its gravity dominates this region, acting as a cosmic bodyguard for Earth by absorbing comets and asteroids that could threaten us. Our journey now carries us to a world that, if it cannot match Jupiter's brute strength, surpasses it in elegance. Next stop, Saturn. Pulling away from Jupiter's overwhelming presence, the sunlight feels weaker, more like that of a very bright star. And then, it appears out of the darkness. A golden globe adorned with the most magnificent ring system we know. This is the view of Saturn, and it is undoubtedly one of the most spectacular sights of our entire journey. Saturn is the second largest planet in the system, another gas giant, but visibly different. Its color is a softer yellow, and it is famous for its low density. In fact, Saturn is the only planet less dense than water. If you could find a bathtub big enough, it would float. But of course, it is the rings that steal the show. They stretch almost 282,000 kilometers across, yet they are incredibly thin, with an average thickness of just about 10 meters. They are made up of billions of water ice particles, ranging in size from dust grains to house-sized chunks. The Cassini mission, which orbited Saturn from 2004 to 2017, gave us an unprecedented view of this dynamic system. The origin of the rings is still debated, but Cassini's data suggests they are young in cosmic terms, perhaps only 10 to 100 million years old. And tragically, they are disappearing. Cassini discovered that ring material is raining down onto the planet, and at this rate, the whole system could vanish in less than 100 million years. We are living in a golden age for observing Saturn. Like Jupiter, Saturn is a mini solar system with 146 known moons, the most of any planet. Many are fascinating. On Enceladus, a small icy moon, Cassini discovered plumes of water vapor erupting from its south pole, indicating a subsurface ocean of liquid water and making it, along with Europa, a prime candidate in the search for life. And then there is Titan, Saturn's largest moon and one of the strangest of all. It is the only moon with a thick atmosphere, denser than Earth's. The Huygens probe, which landed there in 2005, revealed a landscape eerily similar to ours, but with completely different chemistry. On Titan, liquid methane and ethane take the place of water. There are rivers, lakes, and seas of liquid methane. Methane rain falls from the sky. It is a dark, cold mirror of Earth. Leaving Saturn's majesty behind is difficult. Our journey now leads us to the frozen outskirts of the solar system, to the ice giants that guard the edge of the night. Next stop, Uranus. After Saturn's beauty, we travel through a longer, darker stretch. Our next destination appears as a pale blue-green sphere. Welcome to Uranus, the seventh planet from the Sun, and the first to be discovered in the modern era, in 1781. Uranus is the first of the ice giants. Its atmosphere is made of hydrogen and helium, but its interior contains a dense mantle of ices, water, ammonia, and methane. It is the methane in the atmosphere that gives it its characteristic cyan color. Up close, Uranus looks oddly calm. When Voyager 2 flew by in 1986, the only spacecraft ever to visit this world, it saw an almost featureless atmosphere. But this calm hides its strangest trait. Uranus is tipped over on its side. Its axial tilt is almost 98 degrees, which means it basically rolls around the sun like a ball instead of spinning upright like a top. This tilt creates the most extreme seasons in the solar system, each lasting 21 Earth years. During summer at one pole, it remains in constant daylight for 21 years, while the other sinks into a 2-decade-long night. It is believed this was caused by a cataclysmic collision with an Earth-sized object early in its history, an impact that literally knocked the planet over. Uranus also has a system of 13 dark rings and 27 known moons, named after characters from the works of Shakespeare and Alexander Pope. Moons like Titania, Oberon, and Miranda are small, icy worlds. As we move on, the sun is now so distant that its heat is almost irrelevant. The cold of interstellar space deepens. We are approaching the true frontier, a world of deep blue and unbelievable winds. Next stop, Neptune. Our journey carries us even farther into the darkness, to the eighth and final official planet of the solar system. At 4.5 billion kilometers from the Sun, Neptune cannot be seen with the naked eye. It was discovered in 1846, not by sight, but by mathematics. From anomalies in Uranus's orbit, Neptune appears as a jewel of deep, vivid blue. Its color is even richer than Uranus's, the result of more methane and perhaps some still unknown compound. And unlike Uranus's calm, Neptune is one of the most stormy places in the solar system. Its most famous feature, seen by Voyager 2 in 1989, was the Great Dark Spot, a storm roughly the size of Earth. However, when the Hubble Space Telescope looked at Neptune a few years later, the spot had vanished and new ones had formed. Its atmosphere is incredibly dynamic. The source of energy driving this violent weather is a mystery, but scientists think Neptune has an internal heat source that stirs its atmosphere and creates the fastest winds in the solar system, with gusts reaching over 2,000 kilometers per hour. Neptune has a faint ring system and 14 known moons. The largest and most intriguing of them is Triton. It orbits Neptune in a retrograde direction, which suggests it did not form there, but was captured by the planet's gravity after originating in the Kuiper Belt. Like Pluto, Voyager 2's flyby of Triton revealed a geologically active world with dark geysers, or cryovolcanoes, erupt in a mixture of liquid nitrogen and dust. Leaving Neptune behind feels like a final step. The giant planets are now in our wake. We are entering a new realm, a vast frontier of ice and darkness. Our final destination is the most famous of these worlds. Next stop, Pluto and the Kuiper Belt. The trip from Neptune to here is the longest of all. The Sun is now just the brightest star in a sky filled with others. We are in the third zone of the solar system, the Kuiper Belt. It is a vast, disc-shaped region much larger than the asteroid belt, home to countless icy bodies, leftovers from our system's formation. And within this belt, our target finally appears. Small, frozen, and incredibly distant. This is Pluto. For 76 years, it was the 9th planet. Its reclassification as a dwarf planet was controversial, but based on the discovery that it was not alone. It was simply the largest member of a vast population of objects in the Kuiper Belt. Before 2015, Pluto was just a blurry point of light. Everything changed when NASA's New Horizons probe arrived, after a journey of nearly 5 billion kilometers. What it found shocked everyone. Pluto was not a dead, frozen world. It was complex, geologically active, and surprisingly beautiful. As we approach, Pluto's most prominent feature comes into focus, a bright, heart-shaped plain called Tombor Regio. Most of it, Sputnik Planitia, is a huge glacier of frozen nitrogen that is slowly churning and renewing itself, erasing craters and giving the surface a youthful appearance. Around the plain, we see even stranger landscapes, enormous mountains of water ice floating on the nitrogen ice, and evidence of possible cryovolcanoes. Pluto has a thin nitrogen atmosphere that creates a beautiful blue haze. How such a small world, so far from the Sun, has enough energy for so much geological activity is still a major mystery. Pluto also has a system of moons. The largest, Charon, is about half its diameter, and some consider the pair to be a double dwarf planet system. After its Pluto flyby, New Horizons continued its journey. We leave Pluto behind and look back at the solar system as a whole. From this vantage point, the Sun is just a bright star. The planets we visited are mere points of light, almost indistinguishable. Our journey of billions of kilometers covered only a tiny fraction of our galaxy, which in turn is just one among hundreds of billions of others. The immensity is beyond comprehension, and yet, in the midst of this vastness, we found worlds of incredible diversity. The greatest lesson of this journey is perhaps one of perspective. Seeing Earth from afar, the pale blue dot, reminds us of how precious and fragile our home is. Traveling through the solar system is not just about exploring other worlds, but also about understanding our own. Our trip ends here, but exploration never stops. Probes like Voyager 1 and 2, launched in 1977, have already crossed into interstellar space, our bottles cast into a cosmic ocean. Now I want to hear from you. Which destination in our journey fascinated you the most? Was it the hell of Venus, the oceans of Europa, the rings of Saturn, or Pluto's frozen heart? Leave your comment below, and if you enjoyed being part of this mission, do not forget to like and subscribe for future explorations. The journey continues. Mission Control, signing off.